What's up, math fans? At this point in the year, you're studying for midterms, or you're even already getting ready for the Regents. So I picked a couple of old Regents type questions. I'm going to do both of them for you. They might even show up on your midterm. You never know. Wink, wink. Okay, so first one, you get 3 lines vertically, relatively vertical. It's a little bit of a diagonal. And then 2 kind of going across this way horizontally. And the question might say, what can you conclude about the lines? So you might say, well, it looks pretty simple here. A is parallel to B. This line here is A. This line is B. They look parallel. You could say B is parallel to C. You might want to say D is parallel to E. D is parallel to E. Something like that. And you're done, right? That's too easy. Nah, it is too easy. You got to do some math. So first thing I'm going to look at is if I have parallel lines, then I have all those angles that are related to parallel lines. I don't know if you remember this, but there was a video that explained if lines are parallel. If they are parallel, then the alternate interior angles are congruent. The corresponding angles are congruent. The alternate exterior angles are congruent. And the same side interior angles are not congruent, supplementary. So let's play with what we know and see if we can figure it out. Because I don't know this yet. This is what I'm trying to conclude. So let's see. If this is 110 degrees, the opposite angle, whenever you see an X like that, the vertical angle, the opposite angle is the same, is congruent. So that's also 110. Great. Here I got 60, which means I got 60. Here I got 115, which means I got 115. That's pretty easy. Oh, look, a 120. So a 120. It's kind of like a puzzle. Fill in as much as you can. What else can you make? What other conclusions can you make? Well, I see a straight line. So this part of the line, of this angle, is 110. This angle, to form the complete line, that's called a linear pair, also known as 2 supplementary angles. Okay? That means it adds up to what? 90? No, 180. So 180 minus 110 is 70, which makes this one 70. So now you just look for circles and fill in the circles. This is 60. This has to be 180 minus 60, which is 120, which makes this 120. I just filled in another circle. Let's fill in this circle. If this is 115, this is 180 minus 115, which is what? 65. All right, and that means this has to be 65. So I'm filling in circles. One more circle to go, fill in that last one. If this is 120, this has to be supplementary to 120, which is 60 and 60. Now let's see if we can make any conclusions. 110 and the corresponding angle is 120. Those are not the same, which means this angle here is a little bit more obtuse than this angle here. If this angle is a little bit more obtuse, that means this line B is leaning over too much, which means B is not parallel to A. So sorry. Same thing here. These 2 corresponding angles are not congruent. So this, B and C are not parallel. So sorry. How about going this way? 120 is corresponding to 120. That works. 60 and 60, etc. So that does work. This would be my conclusion, that D is parallel to E. It's pretty simple, but you got to be clever with your eyes. You got to know what to look for and where to look for it. So just think about all the stuff you learn about parallel lines and it should come to you. Here's another question that should show up on a test. In triangle ABC, measure of angle A is blah, B is blah, and C is blah, right? So what do? You draw ABC. If you're in a rush, then draw quickly, or you can get your straight edge. Now my triangle might look equilateral, but the point is, I don't know what it is. You might even want to exaggerate it when you draw it so that it looks scalene. The question is, so let's see, here's A, here's B, and here's C. And it really doesn't matter how you draw A, B, and C because Angle A is 3x plus 5. So no matter where you put your A, you're still going to put a 3x plus 5 right there next to the A. B is 4x minus 15. And C is 2x plus 10. And then I'm done, right? No, because the question is going to say, determine what type of triangle this is, or solve for x, or is angle A congruent to angle C? So in order to get to those questions, you got to be able to figure out what the relationship is between three angles in a triangle. Hopefully you remember that the sum is 180. So you're going to make an equation. And what does your equation look like? It looks like 4x, I'll start from here if you want, 3x plus 5 plus 4x minus 15 plus 2x plus 10 all gives you a total of 180. Once you got that, hopefully your algebra skills are strong enough to solve for x. So let me get my like terms all together. 3 plus 4 is 7, plus 2 more is 9x. 5 and a negative 15 and a positive 15. 5, negative 15 leaves me with negative 10. Negative 10, positive 10 leaves me with 0. So I have no number to bring down here. Equals 180 drops down. That's easy enough. Divide by 9 and x equals 20. Whew, that's a lot of work. Now the question might ask you something like, well, once you found x, what type of triangle is it? So I'm still not 100% sure. What do I do? Wherever I saw an x, I'm going to plug it in. So 3 times 20 plus 5, which means the measure of angle A is 65. The measure of angle B is 4 times 20 minus 15. That's 80 minus 15 is 65. Ooh, very nice, very nice. And 2 times 20 plus 10 is 40, plus 10 is 50. Measure angle C is 50. What type of triangle is it? Hopefully you know that if two sides are the same, it's isosceles triangle. They might even really get challenging and say, what conclusion can you make if it's isosceles? And they might ask you which two legs are congruent. It's pretty easy to know that angle A is congruent to angle B. So these two angles, these two are congruent. But which two legs are congruent? If these are the congruent angles, can you figure out the legs? This is very important because you might get asked this on another question. If you're used to, and everyone's used to the basic isosceles triangle, ooh, draw an isosceles triangle. So they draw it, and they say these are the legs, and they're congruent. And if these are the legs, then these are the base angles, and those are congruent. So if you're used to that, you have to be able to spin it in your mind or on the paper. So if I spin this thing, because you're saying that A is 65 and B is 65, that means these are the base angles. So if you spin it, this leg and this leg are the congruent legs. All right, that's opposite to 65 here, opposite to 65 here. So that means AC is congruent to BC, AC is congruent to BC, and that would really be a solid conclusion on a very rigorous test question. All right, good luck on your midterms. Thanks for watching. See ya.